Hi, I'm DJ Ware. On this episode of the Cybergizmo, we're going to talk about edge computing right after this. So, you probably have heard this term before, and you probably have wondered, what the heck is edge computing? So today we're going to take a look at that, and but before we do, we need to look at a couple of other things as well. We need to discuss what is centralized computing, and what is distributed, and what is hybrid. Then we'll talk about edge computing, and then we'll talk about why we need edge computing. What is that all about? And then we'll wrap it up, as always. So let's dive in. Let's take a look at centralized computing. Centralized computing is when a client machine talks to a centralized server. In the old days, that was a terminal. It was originally called mainframe computing, and it usually required some slow method of sending data to a mainframe and then getting it back. Today, however, it means that your machine tied to the internet is communicating with a service or a number of services that are on some back-end computer in the cloud. And so that's really what we're talking about. It's an old model. It's been around since the 1940s. And AWS is a pretty good example of centralized computing. Of course, there are others as well. In distributed computing, this is peer-to-peer. Every computer on the network talks directly to any other computer directly on the network. There isn't any middle server that it goes through. It just talks directly to it. Skype originally was peer-to-peer, and that's a problem. And it isn't anymore, but it used to be peer-to-peer, whereas if you made a call, then it would then attach directly to that other person's machine, and then your communication would begin. So data can be synchronized between the machines to keep them up to date if that's needed. If I have to have data that's needs to be updated, if I do something on one computer, I need to tell the others in the network what's going on. And distributed computing is also old. It goes back to the 1960s. Edge is the new name for distributed computing. And a good example of distributed computing is, of course, BitTorrent. Hybrid computing is something in between. You have some communication that's going direct between other systems, and you have some processing that occurs on those distributed nodes, and that processed data is, reduced and distilled, and then it's sent up to some centralized server. So it's kind of halfway in between the centralized and the pure distributing. The idea originated back in the 1980s. It was called client-server back then, or surround strategy. I remember that name being used as well. Today, it's called fog computing, and wind farms use hybrid computing in order to optimize energy production in that they get weather forecasts and they receive that, and then they turn the blades on so that they're ready to process the incoming winds if needed. Or it could be that you have a whole series of wind farms and you want to know which ones to optimize in order to get the most amount of energy production for that particular day. So that'd be one example of that. So edge computing basically is moving the essential computing and data from the centralized cloud to some front end. And right now that is occurring at the ISPs. If you've done a ping on Google, for example, on Google.com, you'll probably notice that your answer is coming back from someplace that's local to your city. Like here in Texas, I get an answer back from the closest city. So versus years ago, it would go off to the main server of Google in order to do that. So the edge is the point where you're, in this case, the ISP connects to the internet. It can be your site as well. I mean, I'm not saying that. I'm just saying as an example, the ISPs are the ones that are currently setting these up. And mostly it's because of mobile devices. They're being attached directly to the cell towers. So the idea is, of course, is to move the services off the cloud and closer to you, the end user. And that reduces the processing load on the cloud. If you look at Edge in some videos that are on the internet, they'll talk about IoT devices. Yes, IoT devices are used in Edge, but IoT devices themselves have nothing to do with, and nothing whatsoever to do with Edge computing. They're just an application that's using the technology. So the benefits of Edge is to reduce the network latency, to increase the bandwidth, and reduce the load on the cloud servers. And basically, it's a proximity solution. In other words, I move the data closer to where it's being used. So, okay, but that's nice, but why do we need Edge? It doesn't really answer the question, does it? So, in AI, there are a number of steps that occur at the edge. So let's consider a self-driving car, for example, where I have hundreds of sensors or even thousands of sensors around the car that are gathering data. By the time I sent all that data to a centralized server, if I could get it up there fast enough, it would probably be too late for the car to take any action on it. So what's occurring is that that particular piece is inside of the automobile itself. So it senses, you have a sense step, which is taking all this data that you're getting from the sensors, and it's collecting it, and it's distilling it, and then it's passing it off to the next step, which is to infer. Infer means that I take all this data and I try to make sense out of it. Do I have a car that's in my lane? Do I have a car ahead of me that's slower than I am traveling? Or do I have a stop sign or a stoplight or something of that type that I need to have the automobile react to? And then the infer says, oh, okay, this is what's going on, and it passes it to the act step. It says, I've identified this as a stop sign, and the act says, oh, I need to stop. And so that's what's going on there. So that's why you need the edge, is because you have all that processing going on. You can't afford to wait for some answer to come back from a remote server that might be tied up with somebody else's car. The other thing that edge computing does is on the learning portion of it. So as it gathers all this data, it'll probably distill it. I can't imagine that it would want to send it all, because if I remember correctly, an automobile will generate about 10 gigabytes of data for every mile that that car travels. So trying to push all of that data up to the cloud, that's not going to work. It would just end up queuing and waiting there for days before it actually got processed. So instead, what will happen is that the data transfer that takes place from the car to the cloud would be to distill that down into some subset of data, a process set of data that can be sent up in chunks. The backend will then perform additional machine learning steps on it to improve its algorithm. And then once it's created that improvement, it sends it back down. I think a good example of that would be in the gaming world. NVIDIA does gathers shadow information about the game, and then they process it on their back-end servers, and then they transfer it down periodically to the game in order to save that step of machine learning. So that would be an example of how that might be used. So the other part of it is data-centric programming. And that's using a lot less code. In AI, you use more math than you do code, and humans still have to label the data someplace. I mean, in the steps in order to perform the learning steps. But there is research that's underway in order to remove that whole machine learning element, and that the machines will become truly artificial intelligence. And that they would be independent of any machine learning task. They would just understand, like we do, they would learn a task as they went along doing it, but they wouldn't require repetition in order to get the knowledge they need in order to work. So anyway, that's way down the road. But as the number of devices increases at the edge, and we're not talking a few hundred here, we're probably in terms of automated cars, we're probably talking about trillions of devices at the edge. the machine learning and sensors will obviously become numerous, and then as that happens, it will drive the cost down. We're starting to see that. I mean, if you look at these two boards, the one on the right is the Tegra 2, and that one was a lot more expensive. I think it's about $700 or so, versus the one on the left, which is the Jetson Nano, which costs about $99. And I suspect that will continue to occur. That sliding down of costs will continue to go. So. We've talked a little bit about the amount of devices, but the steps that have to occur in machine learning are, I have to gather the data someplace. I got to prepare that data, put it in some format that I don't flood my whatever server is doing the machine learning, and then choose a model. What am I trying to do? Am I trying to recognize stop signs? Am I trying to recognize stoplights? Am I trying to recognize where I am in the lane? But choose the model and then pick the data to go along with that, and then perform the training steps. Evaluate how well that the machine responded, and then do an evaluation. Put it through some paces to see how well it's going to actually perform in the real world. Then I would do some tuning. They call it hyperparameter tuning, but it's basically just looking at the data that failed and then trying to figure out what it really needs to understand in order to prevent it from failing. We don't want that. We don't want it blowing through a stop sign or a stoplight or moving off the lane and into the oncoming traffic. That would be really bad. But and then we would want to do some prediction with that to see how well the model is performing. So if you're confused at this point, let me just say this, that distributed computing is at the far left of the curve. That is pure distributed computing in all of its finest. And then on the right, centralized computing is all the way to the right. For my past career, this pendulum has swung from centralized to distributed and back 4 times. I've been through this migration 4 times, and we just don't seem to get it. The sweet spot for the distributed versus centralized is right smack in the middle. You want to do both. You want the data closest to the user, but you still want the power of the centralized machines to take some of the load off the distributed and coordinate the distribution of the data back out to the distributed servers. I can tell you that I was involved in one of the very first distributed systems in the country, and no, I didn't implement it. I was upgrading what was there. It was a 22 milliamp current loop, 110 baud machine. Yeah, the whopping 110 bits per second. But it transmitted sales data and production data out of the factories to the central machine constantly. It was just constantly updating as fast as 110 baud would allow it to do. But the distributed model, we replaced it with a hybrid model because as the data volume grew, we had to go to faster networks. And that's what I was working on, was replacing the old system. No, I'm not that old. 22 milliamp was long before my time. But we were replacing those systems and putting more intelligence out on the factory floors and having that data come up. And of course, the data grew in volumes and volumes. And so the speeds increased. So we still needed the power of the mainframe in order to be able to process that information and make sense of it, and then send back strip files back to the factory floor so that it would know first what to gather, how to process what to gather, and then what to send back. And so that's what was the whole purpose of it. But hybrid has always been the best way to do things. I don't know why this pendulum keeps swinging, but it does, and it's silly. We can just I don't know if we just don't learn anything in between models. Enough about that. So anyway, Gartner predicts that the traditional data center will be dead by 2025. I think Gartner is completely wrong. And I've got 4 reasons why I think they're wrong, is that I've seen this pendulum shift all along. Distributed by itself is chaos. You just cannot keep up with needing to send updates to every machine in the network. And can you imagine if you had 1 trillion edge devices trying to keep them all in sync? That's an impossible task. That's even worse than the one sending up 10 gigabytes of data every mile to the centralized server. Centralized doesn't work simply because it's too slow, can't handle a lot of data, and in a lot of times where you have real-time processing, it isn't quick enough to respond. So you need something in the middle to be able to deal with it. enough said it from me. That's my experience, and I'm staying with it. But every problem comes with a solution. That's my law. Every time we come up with something new, we create a new problem that we have to solve. Centralized processing is impacted by high processing loads. We talked about that. Distributed processing is a synchronization nightmare, and it just becomes total chaos. Hybrid computing keeps the data closer to the user and still maintains the ability to process and maintain data for all of the machines to share. Best choice. Edge wrap up. I'm just going to say this: that as we discussed in the slides, the centralized computing simply can't keep up with voluminous amounts of data. Edge computing can't possibly keep up with all of the movement of data between all the distributed nodes. Hybrid computing is the most likely thing to be chosen, and so fog, I think, will be the one that's used going forward. The things that I've discovered through my life is that you want to keep the data closest to where it's used. You want to create metadata to ship it around to the other sites so that they know where the location of the data is, if they want to be able to gather it. And then you want to distill that bulk data down as tight as you can, as small as you can, get rid of all the junk that you don't need to send up to a centralized place, and then bulk transfer it up to the centralized server via lazy writes. Just get it up there whenever it needs to get there. And so I hope you enjoyed today's talk. If you have any opinions on edge computing, some things that maybe you'd like to add or some questions about, I'd be happy to answer those as best I can. Like I said, I know marketing always likes to change the name on it because they don't want you to think that, this is something, they want you to think this is something new, not something old, but in fact, it's really old. This stuff's been around a long, long time. Hope to see you all again real soon. Please like and subscribe. Bye for now.